Today we welcome Heath Henley from FarSounder. Heath has worked at FarSounder Inc. for almost 8 years. His current title is Senior Application Engineer. He works primarily on software development, research and development, technical supporting, and customer training. Summary materials for this webinar should be sent out in the following week or two to all the registrants today. And the speaker's contact information is heath.henley@farsounder.com. So without further ado, I'm going to hand it over to Heath and let him take it away.
Awesome, thanks so much. So I'm Heath Henley. I'm going to be talking to you today about a crowdsourced bathymetry-based product that we're developing using our forward-looking sonar system that we produce and manufacture. It was supported by a NOAA-sponsored SBIR Phase 1, which for those that might not be familiar with it, it's a small business innovation research grant. It's a federal grant. It took place over 6 months. We just finished it up at the end of February. And the idea is, because this one was sponsored by NOAA, it's to accelerate the commercialization of technology that supports NOAA's initiatives and goals. And for our case, that was collecting and sharing ocean data more widely. I'm going to tell you more about it, but it's actually a really exciting project for me to talk about because the sort of core, like not the final version, not what we did with NOAA, but the very core MVP version of it, or what it's based on, was what I worked on as an intern a long time ago when I first started with FarSounder. I'm just going to turn off my webcam now so that we don't have any bandwidth issues. So that's the project I'm going to tell you about. Let's see. Oh, there we go. Okay, so I know that there are a lot of people on this call that are very experienced with ocean mapping. I'm including a little bit of introduction that's going to be super basic for you, but I want to do it just so that we motivate the work properly and so that everyone's kind of on the same page. So I know you've all seen the JEBCO map. This is showing, all of the public and some non-public data that we have for mapping the ocean. There's still a lot of gaps there, right? So we've had a lot of advances in the technology that we use to map the ocean over the years, going from lead lines to single beams, and finally now we have high accuracy survey grade multi-beams. But still, the ocean is huge. We've made a lot of progress, but there are big gaps. Even with the technology we have, about 50% of US waters are not mapped adequately. In other countries around the world, the number is a lot higher. The reasons include just the size of the ocean and the limit on the Hydrographic Office's resources that they have to contract official surveys. And multi-beam becomes more efficient, obviously, as the water becomes more shallow. You have a smaller swath and it takes more work to cover the same area. So using traditional methods would take a very long time to fill in these gaps, right? So it might not be completely feasible. So looking at other ways to fill in these gaps and collect this data is a good idea, and we're starting to do that. There are a lot of vessels on the water today. Most of them, even the smallest vessels, have at least a GPS and an echo sounder that they use in everyday navigation operations, just going from point A to point B. Crowdsourced bathymetry involves basically leveraging those vessels' opportunity to collect the depths and the times and their positions from their traditional navigation sensors and get them to people that can use them. So there's a lot more of them. We can increase the coverage and improve mapping coverage that way. There are other vessels out there that also have more sophisticated sensors. And so instead of just a GPS and a single beam, they might also have a multi-beam echo sounder. They might also have a 3D forward-looking system like the ones that we produce and manufacture. So there's a couple different sort of subsets of crowds that we have available for crowdsourcing efforts. You have the sort of general crowd that could be quite large, with smaller boats that have a GPS and a single beam. Sometimes the issue with this crowdsourced data from these boats is that you don't really have a lot of information about the metadata. So aside from the sensor itself, the quality of the data is difficult to assess because you don't really necessarily know all the horizontal and vertical offsets between the reference for the GPS and the actual sensor itself. On the other hand, you have systems that, like the larger vessels that we work with our forward-looking system, I'm going to introduce shortly, but it's typically a smaller crowd, but with a lot better quality metadata. At least in our case, with the way that we install and commission, we typically will get actual drawings, and we know where not only our sensor is relative to other sensors on the vessel, but also the single beam echo sounder offsets and vertical offsets as well. So we have larger crowds that might have lower quality metadata, and smaller crowds that might have higher quality metadata, sort of like a trusted crowd. And of course, collecting data from that trusted crowd is valuable, but it's also got other use cases where you could actually transfer data quality where you have overlap and use it to sort of cross-check the data from the larger crowd. But that's sort of the topic of another discussion, but another talk. But I just wanted to give some of the use cases for the data. But I mentioned our system, a 3D forward-looking sonar used for aid in navigation, and I just want to introduce that system just to give you an idea of what I'm talking about. So what are we doing? We make a system that's mounted on the bow where it's a forward-looking sonar for aiding in real-time navigation. And the general question we're trying to answer is just looking ahead of the vessel and seeing what's there before you get there. Avoiding groundings and collisions that cost money and lives and can have negative environmental impacts, and facilitating exploration of places that the operators of these vessels want to go. To give a little bit more of an overview of how we're installed, we have a unique system. It's installed on the bow looking forward. Depending on the product that you're using, it goes between 350 meters out to 1,000 meters. We're usually about a meter down on the bow, and it looks up to the surface and also down to the seafloor. It generates that entire field of view, updates that entire field of view with every ping. And we're also looking out to the sides. So you get between 60 degrees to the sides or 120 degrees, depending on the operational mode that you're in. So shorter range, we can go wider, as you can imagine, and longer range, we go a little bit narrower, so up to 60 degrees. So the complete picture that a vessel operator will have, well, obviously their radar is going to be looking forward above the water. Our system's looking forward below the water from the sea floor to the sea surface. And we have typical single beam echo sounders or multi-beam echo sounders will be looking down. That's kind of depicted in this red area. Our system is this green sort of cone, and the radar will be above the water, obviously. So yeah. So what does this look like actually playing through some data? Here's an example of a zoomed in view of our 3D viewer. So we're generating this complete image every ping. Everything that's in the sort of field of view looking pie wedge thing that's all real-time data. Everything behind that is a history. And you can see here we're navigating along a shoal to the port side. It's shallower, yellow means shallower, blue is deeper. That's all adjustable, but it's just given as an example. And just to give an idea of the segments that we work with, since about 2005, we shipped our first product. We have been serving the superyacht market, expeditionary cruise, and government and military segments globally. And some of the things that customers use our system to avoid will include icebergs when navigating in polar regions, at least while they exist, large whales, marine mammals, whales, things like that, rocky pinnacles, shallow sea bottoms, coral heads, shipping containers that could be lost, or any other water column hazards, or unmarked obstacles, or maybe things that might be submerged at high tide and exposed at low tide, things like that. So that previous example that I showed was kind of zoomed in on the 3D viewer. This is what the system looks like that's running on the actual bridge of the computer. This is what the user interacts with. What I was mentioning before, inside that sort of pie wedge, that's all live data. But everything behind that, we're actually creating a history map of the depths that the system has seen. So it's basically taking the depths that the system sees in front of the vessel, and averaging them on the fly and creating sort of a depth map. And that's the history that we're storing. We're calling it our local history map. And this is the same idea. This is just a couple different screenshots or screencasts with the chart viewer on the left-hand side. And we're generating this bathymetric map on the fly. We're storing it locally. So classically, before this project, we have this bathymetric map that we're storing for the customers to use locally. Some of the use cases that they use it for included anchor surveys. So it's not a survey in the grade that some of the people on this call probably refer to as survey, but they're doing sort of a few passes quickly before they put the anchor down so that they can store that history and they know when the vessel turns on anchor where the bathymetric features are relative to where they were when they started, relative to the bow of the vessel. And there's also, you can retrace your previous route. So if you're navigating somewhere, the next time you visit, what the depths were the last time you were there. But as we introduced this feature, and so this was actually what I worked on when I started as an intern, just the general implementation of this feature to take all the depths and aggregate them, digging into the OCS field procedures manual and things to get some hints. But we wanted to see, now that we're storing this locally, we have a use case for customers locally. Are there other organizations that might be interested in this data? Can we get it off the vessel and do something with it? And might there be a business case for some type of product based on the data? So we had heard about the crowdsourced bathymetry working group. So it's an organization connecting people from NOAA, the IHO, and hydrographic offices that are member states of the IHO, and a bunch of different industry partners. And this working group was established to develop guidelines for companies that had access to crowdsourced bathymetry data to contribute it to a publicly accessible crowdsourced bathymetry database. And that's hosted at NOAA's Data Center for Digital Bathymetry. So we joined that working group in 2018 to sort of get some ideas, meet people in the space, and see if there was a use case for the data. And right away, we realized that yes, we can definitely start to contribute at least the single beam echo sounder data that we're able to connect, and then eventually probably some of the forward-looking sonar data, which I'm going to talk about shortly. So we became a trusted node basically right after that first meeting, and we continued to participate. I participated in the first meetings, and more recently, Matthew Zimmerman has been taking over participating in the working group meetings from here on. But around the time of that, we started a manual data drive based collection program, which I'm going to tell you about now. So we wanted to do this as sort of a proof of concept. We had no way still to get data off of the vessels. And at the time when we first started to look at the idea of this, it was 2018, it was somewhat less common on these vessels to have internet connection be allowed on the bridge computers. But we still wanted to explore it, and even if it doesn't scale, we wanted to see what we could do with the data. So we actually started to just take these 5 terabyte drives and put some recording software on them and literally just put them in this cool case, send them to customers. They get it, they plug it in, it records data. When it's done, they send it back, and we just send them a new drive. And shockingly, almost, that worked, right? So we get a lot of customers with a sneaker net type approach, proof of concept, that were willing to participate. We got about 80 terabytes of data back through this program from all over the world. So you can see, obviously not to scale, but these are tracks from customer data that we've received, and it's just literally like all over. We submitted a lot of that single beam echo sounder data because we were able to connect to all of the streams that the vessel had access to. We submitted a lot of that to the DCDB, and we used a lot of the data that we received for engineering improvements. Still, this program, the way that we're doing it, obviously is not scalable or sustainable. It did generate awesome data that we could use for engineering testing or engineering improvements, processing improvements. We get to see how the system was working in a number of different environments under different conditions on different vessels. So that was great for algorithm development. And we also were able to contribute to the DCDB and through the DCDB to Seabed 2030. But we were doing a lot of this essentially manually. So we'd actually have to receive all the data back on the drive, process it, and manually run a script to submit it to the DCDB. So a lot of labor involved. And I mentioned there were a lot of customers that were happy to participate. There were some that saw the early adopter type of customer that could see the longer term benefits to use that to incentivize their participation. They were willing to do it. But I would say, the average customers that have a lot, that are very busy and they have a lot going on, there's not a lot of immediate incentive for them to do this. They have to, receive the drive, often internationally, install it, monitor it, send it back, and there's not really a lot of immediate incentive for them to do that extra work. But the fact that some customers were willing to participate and we get so much value out of the data, we wanted to look at, is there a business case, some way to make it sustainable? And that's where we proposed a phase one. So we wanted to propose this phase one to automatically collect and synchronize the data, but also we want to make sure that we make it as easy as possible for users to contribute, no extra steps or as minimal extra steps as possible. Essentially, what we ended up doing is it's literally just an opt-in button, a pop-up that says, do you want to participate in this program, and make it as easy as possible for participation. And also we want to incentivize them to contribute the data because that adds value to the product. And the system that we're using at the moment is just if you contribute to the product, you can get access to the product. And how are we going to make it so that solves sort of the incentivization part of the process. The next part is we're looking at how can we make it a sustainable product in a business sense. So what we're planning to do is for users that want to benefit from using the aggregated product, it'll be a small subscription fee because they're not going to be adding value to the product. They'll still be using it, and that could be either just very, very private users or potentially military or government customers that don't want to make their data available. And also integration into other systems. So integration of the aggregated anonymized product into other chart plotting software, ECDIS systems, voyage planning, or even we talked to some sonar performance estimation companies where they're doing acoustic modeling and they use bathymetry data as input to the model to estimate sonar range under different conditions and things. And when there's not a lot of chart data available, they need to turn to other sources. So there's a lot of different sort of third-party use cases for this type of data, especially in areas where charts maybe are not up to date. So that's what we did. We proposed a proof of concept for the phase one, and it was awarded. And the idea was we're going to take a small group, roughly 10 of our existing hardware customers, and develop the ability to collect and aggregate their depth data, create a data product for them, and send it back, all leveraging internet connection and in the cloud, and having it synchronized. All their data will be anonymized and aggregated and then sent back. And that was sort of the goal for the phase one, to develop that proof of concept system, get it all working and work out all of the scaling issues and things like that. For phase two, we want to, if we hopefully get a phase two, we've proposed a phase two to continue the project based on the success of the phase one. We want to expand to all of our hardware customers, but then to make it available in different ways to other mariners through third-party integrators, as I was mentioning before, so those other software systems. That's what we're looking at to do for phase two. So the immediate value adds for this project for vessel operators, for our customers, they improve their information that they have about their environment, and they can see that immediate feedback so that we don't have to rely on just the early adopter type of customer. They get rewarded by contributing right away. And the immediate value for NOAA, which is why they sponsored the phase one, was that they we've committed to contributing the data or subsets of the data to the scientific community through the DCDB crowdsourced bathymetry database, and also a multi-beam database at NCEI for the forward-looking data that we're gridding. I'll talk about that in a second. So that's what we set out to do, and that's what we accomplished. This is sort of a super simplified overview. I didn't really know how much detail to put up here, but if there's questions, please, we can discuss it. This is sort of the flow of the system.
I do have a question that came in. Can we go to that real quick?
Yeah, of course, yeah.
Okay, so this is a question from Matt, and you may have covered some of this, but it says, if the data is to be used as authoritative, how are they accounting for things such as ship movements, tides, equipment locations to ensure it meets IHO standards? Or is that not the intent? If not, is there a caveat the data is not being used for navigation? Or more simply, how is the data quality controlled or assured?
Yeah, that's a great question. So there is a caveat to not be used explicitly for navigation. We're just providing the best data that's been seen in these areas. At the same time, though, we are correcting for tide. The sensor that we're using, let's see if I have, I don't have a picture of the sensor. We have an IMU inside the sensor, so roll pitch is corrected at the time series level when we're collecting the data. Let's see, what are the other questions? Tides, we're using tide data when it's available. I'm actually using NOAA's endpoints for that. So it's using data from water level stations or tide stations when it's available, and if not, when it's not available, using models to predict, which of course is more variability in that, but that's the best that we can do. We're working globally, so we're not always in US water where we can rely on NOAA's tide stations. So we basically set up like a wrapper system that will connect a bunch of APIs, so we can request, here's the position and the time that we want information for, and it will checks NOAA first, essentially, and then falls back to models. And we're correcting when we're at whatever the chart datum for the vertical reference is in the waters that we're in, we're correcting to that. So in NOAA waters, it's almost always mean low water. And then outside of that, it's usually LAT, I think it's lowest astronomical tide, something like that. So we're not producing survey grade bathymetry data. It is swath bathymetry, but we're not going out doing S44 based order, special order surveys. We did let's see. I'll actually have a little picture of the tide API. So this is just to show like how it works. We have we can send requests and get back the information from, basically just wraps a bunch so that we can not have to do that, decouple it from doing the decision of which API to call. We did some comparisons, because your question is about accuracy, we did some comparisons in the Narragansett Bay of just our gridding approach compared to NOAA data, NOAA multi-beam survey data in the same area. So we did, sort of unofficial surveys. We just kind of went out and, mowed the lawn, recorded the data, and compared to what we had in the NOAA data in the same area. And the other thing we can do, I don't have the slide in here. Yeah, so that's how we did a comparison. We also looked at the variability in the data and used that as an estimate of the uncertainty, and then we compared that to the special order, order 1A, order 1B sort of limits. I know that there's been a new proposed method of grading surveys too, but this was earlier, that we did this in 2017 or 2018. And we can see that a lot of the data falls, we can see where a lot of the data falls as far as the uncertainty in vertical in as far as the total vertical uncertainty. Let me see if I can show you that. Can you guys see this new presentation? This was the presentation that we gave as part of that work. And yeah, so it's going to be kind of hard to see in this one. Can make it better. So this is this sort of hex histogram is showing the density of points that fall under order 1A in uncertainty, just to give you an estimate. And then in these surveys that we performed as part of this work. So you can see, yeah, we have a good amount of points under it and some points over it. So the goal is not to perform a hydrographic office level official survey. The goal is to take advantage of the data that we're getting from these vessels of opportunity. And as far as I understand, NOAA's sort of philosophy is just always using the best available data that you have and openly sharing data as much as possible. So does that answer your question, I hope?
Yeah, that was pretty in-depth. We'll see if he has any follow-up questions. Thanks.
Okay.
Oh, he says, yes, thank you. I haven't been to the JEPCO site in a while. Is this data explicitly marked as not for nav, or is it buried in the metadata? And does it show how is it collected?
I'm not sure about that. That's a great question. It definitely shows what it was collected with in the data. And we haven't, let's see, what we're submitting to the DCDB is all single beam echo sounder data. That's all reflected in the metadata. What we're going to be submitting, because we need to use a different endpoint, it's still going to be publicly available, but what we're submitting to the NCEI is going to be sort of a downsampled gridded data, and that's not going to be for navigation. It's going to be 50 to 100 meter grid in that case. So that's not going to be super useful for navigation. It's just useful for collecting the ocean data and mapping the ocean. And that will be, it'll be noted that it was collected with a 3D forward-looking sonar in the metadata for sure. But as far as what the data looks like in the JEPCO grid, I actually have no idea. But yeah, thank you for the question. Anything else on that one?
Let's see, I just heard a response. Oh, he says, thank you.
Oh, great. Ah, awesome. This is awesome. So if anyone else has any questions, it's great to make it more like a discussion than just listen to me talk. That would be cool. But so, yeah, so everything in the green and the blue, these are new things that we added. So we have this software that's running, processing and displaying the data for the user to use. We have green services that we added to actually take that data that the user is working on and synchronize it with our new cloud services. So there's an API server that kind of works as like the gateway. So these services send up the data to the API server, it sends it to a data store, and then there's a bunch of stuff that does a lot of the cleaning that we were just talking about, the tide correcting. It aggregates it into a grid and gets it ready to go back. And then the services on the user's system say, hey, is there new data available? And it gets it from that server. There's also these same type of cloud functions that take that data, package it up, and send it to the DCDB. Right now, this is working with the multi-beam, with the single beam data. It's going to be working with a downsampled grid of our 3D FLS data too, but it's just going to a different endpoint, still publicly available. So that's what we put in place. And sort of the way that the system looks on a very high level, simplified sort of overview. But how do we test it? So we have like a rack of computers that we use for testing our test stations in-house. So really we knew we wanted to deploy it, excuse me, we wanted to deploy it to about 10 customers to start. So we set up those computers to just run, to pretend to be basically 10 customers and just run through real data in shallow water just constantly. So we set up a mirrored like development environment, and we synced this. We synced the incoming data to the development environment, ran it through all the processing, and had it sync back. And that helped us identify a ton of bottlenecks, a bunch of performance issues and things that I missed. But once we fixed all that and we were happy with it, we took it on the boat and tested out live. So we connected connected to it live, shipped it all up from the whole day of a boat test and sent all the data up and shipped it down. Just had like a sort of a real test of the system, even though the stress test was running through real data. It actually was a pretty conservative stress test because we simulated 10 very, very active contributors because, you know, real vessels are not always in shallow enough water to send up data. They're not always running 24/7. Usually they're on anchor and port and they're running for a couple hours at a time. So this was, you know, sort of a nice conservative way to make sure that we were going to be able to handle it once we shipped it to 10 customers. So some of the challenges that we have, we still, not all the hydrographic offices are totally supportive of crowdsourced bathymetry. And we decided to be a little bit conservative and use the same filter, same geofilter that the IHO, the crowdsourced bathymetry database, is using for their data. So everything in green that you're seeing in this filter is all places that are explicitly for crowdsourced bathymetry. So if you're in the US, it's fine. Sharing data is encouraged, right? But it's not that way everywhere else. So everywhere that's clear, they either didn't respond when they were asked if they support crowdsourced bathymetry in their territorial waters, or they explicitly said no. As we're a private company, it doesn't necessarily map to us. We don't really know that we need to be this conservative and follow what the IHO is doing. But to start out, to get something going for phase 1, we decided to just use what they're using. So it's something that we want to look at more in phase 2. This is more about the challenges with that geofilter and the hydrographic office's concerns. I'm not going to go through it, but it's in the slides. If you're interested in learning about what their objections are to it and things, there's some references that you can read through. The current solution that we chose to go with is basically we'll run the geofilter and exclude data into the aggregate product so that you just can't access shared data from the places that they haven't been. So we're not really breaking anything with that geofilter. But we do leave the data in the individual user's backup. So the individual user can access data that basically it's so that if their system, their hardware on board, their computer hard drive crashes or something, they still can get that data that they backed up previously. And we're going to reevaluate these limits in phase 2 because it might be that some countries actually aren't opposed to it and they just didn't respond or something like that. So that's the challenge with the geofilter. Some of the other challenges were actual internet connection. This is changing a bit because of Starlink. More and more vessels are just able to have consistent internet connection. It's not a problem, but to overcome the issue where you might not be able to do that, we're caching everything locally. So basically everything is recorded locally as it was before, and then when it sees connection, it sends, synchronizes basically with the cloud. But with that, now that we're not an isolated system anymore, there's cybersecurity concerns. So we're following all the best practices that we know about, but we're also going to be getting input from a third party, doing like a sort of an independent audit to see what we can learn there, and doing everything that we can to keep customers' data safe now that we're actually on the internet. So
we have another question.
Yeah.
Oh, I lost my box. Hold on. There we go. All right. So it says IHO CSB working group is investing on B12. Will FLS data be aligned with it?
That's a great question. Yeah. I think there were some efforts to make B12 equipment agnostic. So I think in that regard, as long as you're just talking about a depth sensor and not talking about single beam explicitly, it is aligned with what's in B12. The issue you had, I think there was a lot of concern with actual survey data being contributed to the crowdsourced bathymetry working group database, or the crowdsourced bathymetry database. And there was some issues with that. But as we're equipment that's used in everyday operation, not to perform a survey, I think it's well aligned. That said, we do have to send it to a different endpoint because they're set up to basically receive points, and we are going to be generating like a grid, like almost swath-like grid of data. So that's why we're going to be sending the FLS data to a different endpoint. It's still open. It's at NCEI as well, but yeah, they're expecting basically point data instead. So I think it follows it in spirit, but as far as being accepted in the same endpoint and the actual having the same data format, it doesn't really work out. So some of the results of the project, we did ship to 10 customers. We have confirmed installs about 10 customers, only 6 active users, which means we've got confirmation that we've sent them the installer for about 10 of them. Either they hadn't run the installer yet, hadn't come out of dry dock or service period, or they haven't connected to the internet yet. But we have 6 that have. We received about 11.5 million grid points from our sensor, and 1.1 million depth points that were submitted to the DCDB just from this program. And it's from all over the world. So we have Bahamas, Panama, Seattle area, and even the Mediterranean. So that's sort of what we have coming in so far. I wanted to show some of the process data. So we have, this is nice and dense with a little bit better coverage because we collected this data ourselves, excuse me, during a number of engineering tests in the Narragansett Bay. And so this is that 4-meter gridded data that I was talking about. We just rasterized it and it's colored with depth. Like the deeper blue is deeper, darker blue is deeper, and the yellow is shallower. This is just showing sort of how the data can look in the system. But I also wanted to show some real data. It's not as interesting because we have mostly just single tracks from vessels like moving around in their normal operations at the moment. But this is sort of a track where a vessel went out of a little bit of a shallow channel and went over a little hump and then down into deep water, where they eventually went out of the depth range of the sensor. This is the same thing. It's just rasterized and colored according to, yellow is shallower, and blue is deeper. So what we're going to do next, we're hopefully going to be expanding the program in a phase 2 and continuing it. We're going to do a full rollout to the whole FarSounder fleet. So going from like tens of vessels to hundreds of vessels, hopefully, doing that in a rolling manner so that we catch any issues that pop up, any scaling issues that pop up as we go. And then working on the business case of expanding beyond the existing FarSounder hardware users into third-party integrations with different types of software. And also I'm hoping to get some help from the crowd here too. We have this new data pipeline where we can collect data at the operator level and send it up to the cloud. The data from our sensor is a lot larger than something like data from a multi-beam, data from a single beam. So it's about 1,000 times more data than what we send up when we're sending up just depth sounder data. And we're wondering what other types of observations could we include now that we have this system that wouldn't really make much of a difference in the bandwidth. So things that we were thinking of, because we know that there are existing endpoints for it, we could have like a pop-up where the user could click and say like, hey, I saw marine mammal, I saw whales here, and record the time and have them put in notes, like just short notes about like what they saw. And the time and position, and then maybe other observations could be debris, floating debris, like large floating debris that you're worried about. We could loop in other sensors, maybe something like sea surface temperature sensor, and send that up. And I think all of those things would be not a significant change to the bandwidth, and we could leverage what we've already put in place to contribute that data further down the line to new endpoints, or to other endpoints that are interested in it. That could be government endpoints, but also other organizations. So if anyone has any ideas for what might be useful to get from an operator in that sense, please let us know, because we're looking to do that. And that's kind of all I have for you. So we put a new system in place to get the data off the vessel, aggregate it into a data product, and send it back. We have 6 active contributors. We're automatically contributing to the DCDB now, which is great because I don't have to take the data off a drive and run a script manually. And we're incentivizing users to do it by basically saying, hey, if you give us your data, you can access the data product that you're contributing to. And we're letting them contribute to Seabed 2030 and the CSB database at the DCDB. This is the team that I worked on it with. Evan helped a lot with the software design and architecture and implementation. Matt, he's more on the business end. He found a lot of the partners that we could work with and did a lot of customer discovery, customer development, and the same thing with Cassie, customer discovery, customer development, a lot of administration, and we all took some of the customer discovery interviews and things like that. So, yeah, with that, that's kind of all I had planned for you. But yeah, hopefully there's some more questions, and hopefully that was useful.
Absolutely, thank you. So there were questions that were rolling in during the presentation, and here's another question here. Again, if you have a question for our speaker, you can drop it in the questions box in the menu on the right side of your screen. So the first question we have here is from Jessica. It says, could deep sea coral be considered for a new data pipeline?
Deep sea coral. That sounds, yeah, that's something to, I think, consider. With how do you detect that? So that's not something I'm familiar with. We're with a forward-looking sonar, we're going down to about 85 meters maximum detection depth. So it's really shallow water that we're concerned with, or shallow, classically. But if there's a way that they can detect deep sea coral and get that automatically up, and it's a small sort of data load or like a payload, then definitely, yeah, that's great. So deep sea coral, I'll note in my notes here. Thank you. Is there any other questions to go through? Are we still, you guys have me?
Sorry, I was chit-chatting on mute. Do that more often than I'd like to. So we do have an update from the webinar that I pitched earlier today, and we did actually move that. That's just very last minute breaking news. So the Standard Ocean Mapping Protocol release seminar is been moved to May 21st at 11 a.m. That is a Tuesday. So it is not next week, it is the following week after that. The registration link should be the same, and if you've already registered for that, your registration should just update on your calendar, but I just wanted to make a note of that. And again, we will be sending out the seminar summary information from this webinar. So if you registered for the webinar or if you were unable to make the webinar, we will share this with everyone. So it'll have the slides, it'll have the recording, and then it'll have an FAQ with some of the links or any other resources that our speaker would like to share with you. And let's see. Oh, we do have a comment. It says, thanks for bringing up such an intriguing topic. That was a comment from Mohammed.
Oh, great. Thank you. Thanks for the attention. I appreciate it.
And there's two more questions that just rolled in. So one is from Brian. It says, have you looked at using B12 metadata alone as a start to get around the fact that B12 data are currently oriented around point data and not swath points?
I'm not sure what you mean by that. Could you expand a little bit? So are you, yeah, do you mind expanding a little bit? I'm sorry.
Yeah, I'll have them expand a bit on that. And then let's move on to our next question then. So it says, have you investigated converting the gridded depths from the FLS to conform to the CSB DCDB JSON standard so you can send it all to the endpoint at the same DCDB? I'm going to copy and paste that acronym.
Oh, I get it. Yeah.
Got it. Okay.
So yeah, so we are actually, yeah, that's how we're submitting the single beam data. So I understand that. And we're working with the data manager with Georgie at the DCDB to do this, and we came to the conclusion that the best approach will be for us to submit the gridded FLS data to a different endpoint. So it's going to be basically we're going to use their program. It's called I think it's called CruisePack to basically make like a template. It might be messing that up, but I think it's called CruisePack, and it basically guides you through collecting all the metadata that you need. And we're going to use that to make a template so that we can package our data, include all the necessary metadata, and it's going to still be GeoJSON, but it'll be a grid instead of just points. And that's kind of what we're planning to do, what we've discussed with them. And they kind of said that that's kind of the best way forward with the resources that they have and the system that they have and what we're working with. But yeah, I think the metadata will be similar to what we're sending to the DCDB's CSV endpoint, but maybe we're going to have to include some different things because it's gridded. But yeah, I think that it's the pipeline that they have set up. I think it's not. I'm not sure about the details of that, but I don't know if the pipeline they have set up is set up to handle not point data. So I think it might just end up drawing crazy lines in between a bunch of the points if we were to send them instead of accepting it as like a grid.
Yeah, and it is CruisePack, just to confirm. And then Anthony says, okay, thanks, that makes sense. We at NOAA Coast Survey are excited to see the data. So.
Oh, great. Yeah. No. Yeah. If you have specific use cases or anything, please reach out and we can look and see if we have data from those areas and things.
And it looks like our previous question, it looks like we lost connection with them. So I'm not sure they're going to be able to follow up, but we always have emails. We can follow up over email. And, you know, while I'm at it, I'll make a pitch and throw Heath's email right back in the chat for you guys so you can copy and paste it. Again, that resource will be sent back out to everyone who registered for today's webinar. So you can always follow up with Heath there as well. Oh, is Brian back? Oh, he's back. Let's see if I can.
Oh, nice.
All right, Brian, I think you're on.
Hello. Yes, thank you. Can you hear me?
Yeah, there we go.
Yeah.
Sorry, I had to quit and give permissions for the audio to work. Yeah, so the question I had was about the using producing and supplying B12 metadata, irrespective of whether you're submitting points or the gridded product. I think the gridded product, you could still use the bare JSON metadata that you know has information about the trusted node, about the platform, potentially about the sensor configuration, where they are, offsets, and any kind of processing lineage. Those sorts of things should still be useful, and it should be workable with what you're doing now. Just so that's what I was wondering about.
Oh yeah, that's an interesting point. That's something that I would discuss with probably with Georgie. But so I think you're suggesting essentially submitting like a track almost that will be acceptable into the point system to say like there's a vessel here with data available and here's the track for it and all of the metadata. But maybe they have to go to some other endpoint to actually get the gridded data, the actual data itself. Maybe something along those lines. I think that's probably possible.
Oh yeah, I actually hadn't thought of that. I hadn't thought of saying here's the track and that. That's possible too. That's interesting. I was thinking. I mean, we have encodings for B12 metadata by themselves.
Okay.
They call it the XYZ encoding, which is just the metadata, the metadata as a JSON file meant to accompany a CSV file. But there's no reason that you couldn't use that to accompany the gridded data, I don't think. So that might be something to think about. And we have a project at CCOM that we've been working on with DCDB, with Georgie, but to provide a schema to do metadata and data, but in this case, metadata validation. with a couple of different, I guess you could say, vernaculars of B12.
Okay, yeah, that makes a lot of sense. That's something I'll look into. Thanks for bringing that up.
Okay, yeah, thanks.
And those that don't know what CCOM stands for, that's the Joint Hydrographic Center with University of New Hampshire.
Yeah, sorry, yeah.
Yeah, no problem. I know it's just acronym soup up in all these, government webinars. So, all right. Thank you. I don't see any other questions rolling in, and we're almost at time. So let's wrap it up. Thank you so much to our speaker today. We really appreciate Heath coming on the line. That was a great engaging webinar. So thank you everyone who threw questions in the chat. I really appreciate that. And we also had folks on a separate Google line as well for some of our secure folks that can't access GoToWebinar today. So always be sure to check registration information for future webinars. We do have some accessibility options for those that cannot access GoToWebinar and also closed captioning. So thank you very much for joining today. This was one of our last IOCM seminars of the season. We'll start back up in the fall, but remember we do have that SOMP seminar that has been moved to May 21st at 11 a.m. Any last comments or words of wisdom from you, Heath?
Oh, no, just thanks for having me. I really appreciate the attention and the opportunity to talk to you all about the project. And yeah, that's it. Hope you have a great week.
Awesome. Thank you so much. I appreciate it. All right. Thanks, everyone. We'll see you later.